Hello everyone, and welcome to Biopedia. We often talk about diversity when discussing biology in the context of climate change or human impact. However, diversity is not one concept and can actually be split into different components. There are, in fact, two components to it in both systems we're going to discuss today. The first of these is alpha diversity and beta diversity. This concept was introduced by Robert Whittaker, the man who introduced the five-kingdom system of taxonomy, these five kingdoms being animals, plants, fungi, prokaryotes and protists, which wasn't really replaced until the later system by Carl Woese, but that's for another time. There's not really an easy way of splitting the discussion of alpha and beta diversity into two, so I'll tell you what they both are from the outset. Alpha diversity is described as the diversity at a regional scale, while beta diversity describes the difference in diversity between different habitats. Alternatively, you can think of beta diversity as the rate of change of species makeup and number as you move from one habitat into another. The idea behind this concept for Whittaker was that both of these components could be added up to show you what he called the gamma diversity of an area, i.e. the total biodiversity in a landscape. Essentially, you would be able to split a landscape or habitat into its different components, measure how diverse each one of these was individually, and then compare between all of them to get an idea of how biodiverse the overall habitat is. Now, I have to say that I haven't heard these terms used very much in my study of biology so far. Instead, you tend to hear more about species evenness and species richness, the second pair of concepts we're going to discuss today. So, species richness would be the number of species in a given area. By contrast, species evenness refers to the proportion of individuals that are in each species, essentially how fair the balance is between them. For example, if 98% of a habitat's individuals were oak trees, then oak trees would dominate the area, obviously, and species evenness would accordingly be low. By contrast, if you have 5 species in an area and each species contains 20% of the individuals in that area, you will have high species richness. As before, these values taken together can tell you about the total biodiversity. This opens the way for different formulas and ways of putting a physical value on biodiversity. However, I feel like that's more of a separate topic, so I'm going to leave that discussion for another time. As always, thank you for listening. Feel free to get in touch for any questions, comments, or future topic suggestions. Until next time, have a great week, everyone.